Hi, I'm Leon Rosenshein, and I'm the Tech Lead Manager for the Software Quality Team at Aurora, which is part of our Developer Experience organization. While I've only been with Aurora for about a year this time around, this is my second stint at Aurora. For the last 15 years or so, I've been working down in the engine room, working on internal tools, platforms, and developer experience at companies such as Microsoft, Uber ATG, Amazon, and Aurora. As the lead of the software quality team, for the last year I've been focused on making sure the Aurora driver has the internal software quality we need now and in the future. I'm not responsible for ensuring that the Aurora driver meets all its external requirements, just the ones that apply to internal quality. So I'm not going to be talking about traditional QA/QC roles and work. Instead, I'm going to be talking about the situation when I started a year ago, our goals, the process we're going through, and finally, talk about what we've learned along the way and some recommendations for others that need to take a similar journey. 7 years ago, Aurora was founded with a mission to deliver the benefits of self driving safely, quickly, and broadly. Since that time, we've fielded multiple hardware versions with our different partners on the test track and on the open road. Right now, we're running multiple commercial loads every day between our Texas hubs. With over 1,200 people in the hardware and software orgs responsible for millions of lines of code written in multiple languages, maintaining developer velocity is key to delivering on our plan to launch in 2024. Starting as a research and development project, the Aurora driver advanced through proof of concept, expanded its operational domain, and is now in beta. Along the way, and as we make the transition into production, our safety case drives us to ensure that we meet internal and external quality standards common in the industry. I'm part of the developer experience team, where our job is to drive software quality, developer velocity, and simplicity while ensuring that we meet those standards. There are lots of issues that come up when working to deliver at Aurora's scale, things you don't always see at smaller scales, and things you only see in a mixed hardware-software development environment. Our developers are not only working with custom hardware, they're writing the custom firmware that goes with it, which means our development and test environments need to support that custom hardware and software. Over the last 7 years, the developer experience has expanded both deliberately and organically, as new tools and processes were created to address the needs of the different development teams. This has led to areas where the tooling and processes work, but they're inflexible, sensitive to errors, and hard to extend when new requirements appear. At the same time, with over 350 interdependent modules involved in the Aurora driver, it can be difficult to determine if and how changes to one module will impact the operation of another. This makes it hard to quickly check for regressions and far-reaching impacts. In the beginning, when the goals were around learning and proving that things could be done, development standards were different. As time has progressed, common industry standards have begun to be applied. Newer code is more compliant, but older code, in many cases, still needs work. Finally, as the scale has grown, not just the size of the code base, but the size of the team as well, the time it takes to do a build, as well as the number of builds per day, continues to increase. All of these things add cost, complexity, and friction to the system, slowing developers down. At the same time, like any other software project, and especially a software project of this scale, with this many developers involved, there are not just technical challenges, but socio-technical challenges as well. Some of the biggest challenges come from the transition from proof of concept and beta to production. While doing research or implementing new features and capabilities, the focus is on making it work. In production, the focus shifts to keeping things working and ensuring that nothing goes wrong. Changing from a local focus to a more global focus on the interdependence between modules instead of what each module does means people need to think more proactively about the possible negative interactions and work to prevent them, not respond to them when they happen. Similarly, because of the late application of standards, developers need to build the habit of applying those standards. The longer they're avoided, the more rework there is. Again, all of these things work together to add cost, complexity, and friction to the system, slowing developers down. Before we could figure out how to achieve our goals, we had to clearly define them. Like any other software project, we had requirements coming from multiple directions. The platform teams themselves had requirements and constraints. Our customers, the internal users, had requirements, and because this is a safety critical environment, the product team, through our safety case, had their requirements as well. The platform teams, the teams responsible for building and operating things like builds, CI, CD, distributed and parallelized data warehousing and processing, internal quality measurement, and authentication and authorization services, worry a lot about efficient usage of resources. They want to reduce the number of tools that people are using and reduce interoperability issues and reduce their support burden. They also need to ensure that things are repeatable now and reproducible later. The simpler and more constrained the platform is, the easier it is to maintain and operate. Our internal customers, on the other hand, are focused on feature development, making sure the Aurora driver understands the current situation and does the right thing. To do that, each internal team wants simple, streamlined operations and tools that are customized to their specific needs. Our motion planning team wants to run hundreds of simulations, while our web services team is concerned about forward and backward compatibility. They both want the tools to be fast so they get feedback quickly and can iterate, and they want the feedback to be specific and actionable so they know exactly where to go and where to look to find and fix root causes. In addition to all the operational requirements that the product teams bring to the safety case, the product teams also tell us about common industry standards, such as ASPICE and ISO 26262. We need to be prepared to meet those standards by doing things such as measuring code coverage, performing static analysis, and similar internal quality measurements. As more and more of the operational requirements in the safety case are met, these quality requirements become more and more important. As you can see, these three groups had goals that were often in conflict with each other. Internal customers wanted specific tools that were tailored to their needs, while the platform teams wanted to reduce the number of tools in use. Similarly, internal customers wanted rapid responses, while the external requirements from the product team tended to increase latency and resource usage. And this all needs to happen as the different teams shifted focus from research and development to production and operations, all in service of improving developer velocity. Again, it's not just a technical problem, it's a socio-technical problem, which means we couldn't just solve the technical problem, we also needed to solve the social side of the equation. On the technical side, it starts with golden paths, shared common ways to do common things, optimized for specific use cases and configurable in the narrow ways that make sense for our use cases. It's using the build system to understand and take advantage of known dependencies, to only update the things that really need to be updated, using multi-level remote builds with local and remote caches. Because we're dealing with not just software, but physical objects interacting in the real world, full test cycles are measured in weeks, not minutes. So we take advantage of that. We keep developer velocity high by having gates to put code on the main branch be different than for a release branch. They are fewer and faster to run. Then we use schedule builds, some hourly, some daily, others on different schedules, to identify gaps where the main branch does not meet the release requirements. Check-in gates look at direct changes and nearby things that are impacted. Things like measuring code coverage or static analysis for changed files, and ensuring direct dependencies build and their unit tests pass. Other things, such as overall code coverage and static analysis, or the full suite of simulation, integration, system, and hardware in the loop tests, are run at scheduled intervals. That gap and the issues identified by those scheduled builds lead right to the social cultural aspects of the solution. We start with the assumption that everyone wants to do the right thing as they understand the situation. The key is to make sure everyone understands things the same way. That means information radiators, not just reports in a shared storage location, but push notification of issues along with pointers on how to deal with the issues. Dashboards that are shown in public places all the time, and websites people can go to and see not just the overall status, but filterable to the status of things that are interesting and actionable to them. It also involves education to ensure there's shared understanding so everyone understands the importance of closing that gap, how it impacts not just their velocity, but their teams and the overall product velocity as well. Education about the tools and how to use them, so everyone can efficiently reproduce issues uncovered in those scheduled builds and go deep to find and fix the root cause. It means ensuring the culture values fixing those issues as much or more than doing new work. We recently took some time out of our schedule to run a quality week. In addition to having everyone focus on things like code coverage and static analysis, every day I sent a summary email. That email included pointers to educational material about the tools and processes we use, badges for people contributing to Quality Week, a dashboard with current status, and videos from senior leadership, such as our CEO and Chief Safety Officer, underscoring the importance of keeping things clean and not being so focused on new work that existing work suffered. And overall, it meant ensuring that everyone understands and is aligned with the goal of improving developer velocity while maintaining the needed internal and external quality. As we continue towards production and launch, we're going to be continuing to improve developer velocity and internal software quality. In closing, here are a few of the key things we've learned so far. You need to understand not just your goals, but the problems you're currently facing. If you don't know where you are, you don't know how to get where you want to be. You need to radiate information. If people have to search to find status or issues, you've made it harder and slowed things down. Ensuring information is readily available makes sure people don't miss it. Improving developer velocity is about developers. It's about people. That means it's a socio-technical problem and you need a socio-technical solution. Key to that solution is buy-in from senior leadership. People want to do the right thing, what they think is expected of them. Leadership buy-in and support ensures that everyone is working toward the same goal with the same priorities. And as we saw in our initial quality week, gamification works. Leaderboards, badges, and general acknowledgement go a long way to getting people motivated. Or to put it another way, in the battle between culture and change, culture wins almost every time. So instead of just forcing a change of tools, processes on your people, work to change the culture to value what you want to happen. If you have any questions, you can contact me through my blog, friengineers.rosenshein.org.